Going to be talking about the absolute and relative refractory periods. But before we talk about these refractory periods, let's look a little bit at voltage-gated sodium channels. Now, we've been looking at the action potential, and we've said that when a stimulus comes and it makes the membrane potential go above the threshold, we get an action potential. And the reason why we get this action potential is because voltage-gated sodium channels open. Now, voltage-gated sodium channels are very unique in that they have three states that you can find them in. They can either be closed, or they can be open, or they can be inactive. So they can be closed, open, or inactive. And how this works is very simple. They have an activation gate, and they also have an inactivation gate. And when the stimulus causes them to open, the activation gate opens, and after 0.5 to 1 millisecond, the inactivation gate automatically closes. Now, what is special about these voltage-gated sodium channels is that once it's open or inactive, it cannot be re-stimulated to open because it's either already opened or it's inactivated. With that in mind, let's go and take a look at what causes the absolute and relative refractory periods. All right, here I am looking at a neuron, and you can see the neuron over here to the right. Here we have a soma, and then here we have the axon, and the main part that we're going to look at today is what is happening in the axon, like we've been looking at in the last. Now, if I'm going to look at an action potential and I'm looking at what is happening to the membrane potential, here you can see we have a stimulus, but it doesn't cause an impulse. We have another stimulus, but it still does not cause an action potential. But if the stimulus reaches a threshold, we have depolarization. For a polarization. What this means is voltage-gated sodium channels, so I'm going to write Na+ for sodium ions. Voltage-gated sodium channels open and sodium rushes into the cell, causing the membrane potential to become more positive. Now, while that is happening, this means that the voltage-gated sodium channels are either open or they're inactive. So they open first, and after a short period of time, they become inactive. While this is happening, no matter what you do, you cannot cause another action potential because this one is already underway, and the voltage-gated sodium channels are either open or inactive. So it does not matter what you do, we will not get another action potential. This is called the absolute refractory period. So we have the ARP for the absolute refractory period because the channels, the voltage-gated sodium channels, are either open or inactive. Now, as I said in the previous slide, in order for another action potential to happen, those voltage-gated sodium channels need to be reset to close. When we reach the repolarization phase and potassium rushes out, the membrane potential starts going down, and as it starts going down, the voltage-gated sodium channels start resetting to their closed state. Once they start resetting to their closed state, you can stimulate it to do another action potential. However, if there are only a few sodium channels reset, it's going to take a significantly stronger stimulus to cause the membrane potential to reach the point where we can stimulate the action potential to happen again. I'm going to say that again. When the voltage-gated potassium channels open and potassium ions rush out the cell, the membrane potential is going to start going down because it's repolarizing. Once that starts happening, voltage-gated sodium channels start being reset to their closed state, and you can stimulate it to have another action potential, but it's going to take a stronger stimulus since you have fewer channels being reset. That is the relative refractory period. And that continues. More and more channels are being reset to the closed state, and when they're all reset to the closed state, that is the end of the relative refractory period. So you stimulate the axon, you get an action potential. Voltage-gated sodium channels are either open or inactive, and you cannot stimulate it again. That is the absolute refractory period. Once they start resetting, you have the relative refractory period where you can stimulate another action potential, but you will need a stronger stimulus. So that's the absolute and the relative refractory periods. I hope it makes sense.